Trigonometric ratio of complementary angles. So, what does it mean? In fact, what is the basic idea behind it? Let's understand it in essence. So, let's begin by considering a right angle triangle. So, I'm going to make it perfect. I'm going to draw it with a ruler. So, if this is a right angle triangle, we know that the longest side of a right angle triangle is the hypotenuse side. So, I'm going to represent that with HYP. Now, the opposite side does varies depending on the position of the angle. But for now, let me just assume this is the opposite and this is the adjacent, ADJ. Now, the base angle, if I assume it is theta, what would be this angle? Since the sum of angles in a triangle is 180, if I assume this angle is x, then it turns out that x plus theta, this is 90 because it's a right angle, plus 90 equals 180. And the goal is to solve for x. So if I should subtract theta and 90 from both sides, I will end up with 180 minus 90 minus theta. And at the end of the day, you notice that x will be equal to 90 minus theta. So I'm just going to replace x with 90 minus theta. Now, if that is the case, let's try to just sort down some things. So get your pens and get your notes ready, because we are trying to observe some relationship or some similarities. According to the first three trigonometric functions, which is the sine, cosine, and tangent, what would be the sine of angle theta? You know, in this case, you have to be very sensitive about choosing your opposite side, as it has to be the side facing that angle. So for theta, this will be the side that will represent the opposites. So this is the opposite. You notice that sine theta will be opposite over hypotenuse. Now, what would be cos theta? Notice that cos theta will also be equals to the adjacent, that's car, adjacent over hypotenuse. So this is the adjacent and this is the hypotenuse. So that will be ADJ divided by hypotenuse. Then lastly, that is tan theta. Tan theta is opposite or divided by adjacent, and that's just OPP by ADJ. Now, these are the corresponding ratios of the first three trigonometric functions. Now, what if we have interest in that of the other angle, that of 90 minus theta? So what would be sine 90 minus theta? Let's see that. Now, before we do anything, we must know our opposites. Now, in this case, this is the side facing the angle. So definitely, the adjacent is now our opposites. So don't misquote it. Don't get it wrong and don't get mixed up. I'm just going to be assuming this is now my opposite and this is now my adjacent. Perfect. So now let me just put O beside it and A beside this. Perfect. So now we know that sine is so, that is opposite over hypotenuse. So definitely sine 90 minus theta will be ADJ divided by HYP. Perfect. Now what about cos 90 minus theta? Cos is car, that's adjacent over hypotenuse. The adjacent is OPP and the hypotenuse still remain unchanged. That will be OPP divided by HYP. And lastly, tan 90 minus theta. 90 minus theta, that is twa, opposite over adjacent. So this is the opposite and this is the adjacent. So therefore, tan 90 minus theta will result in ADJ divided by OPP. Now at this point, we need to inspect. What do we observe between the ratio of 90 minus theta and that of theta? You notice that sine theta, which is opposite over hypotenuse, produces the same ratio as cos 90 minus theta. And this brought up the idea of complementary angle of trigonometric ratios. So what you need to keep in mind is that, okay, let me get rid of the triangle. I don't need that anymore. So you need to know that sine theta is equals to cosine 90 minus theta. So that's why I show you the proof right from the beginning of this video. So if you can't cram it or master it with some examples or practice problem, you can just master the proof. So you can always use that to recall. Now, do we notice any other pattern? Notice that cos theta, which is adjacent over hypotenuse, produces the same ratio as sine 90 minus theta. So therefore, cos theta is equals to sine 90 minus theta. Now, what about tan theta? Tan theta is opposite over adjacent, but tan 90 minus theta is adjacent over opposite. So that seems to be the reciprocal. So therefore, tan theta equals to the reciprocal, which is 1 over tan 90 minus theta. And from the reciprocal functions, we know that 1 over tan theta corresponds to cot theta. So definitely, tan theta is the same as cot 90 minus theta. And these are the first three trigonometric ratio of complementary angles. Now, how can you be tested on this? Let's consider some examples. Hopefully, you got that. Example number 1. Consider sine 2x plus 10 to be equals to cos 30. What would be the value of x? Feel free to pause the video and find the value of x. So now, we know that this problem can be solved in two different ways, and I'm going to consider the both way. However, we'll be referencing to the formula we have discussed earlier. So let's begin with this one. Cos theta equals sine 90 minus theta. We can use this formula to solve the problem. However, we can use another one. That will be for the second case. So now, what I'm going to do is to consider cos 30 to be equals to sine 90 minus 30, which will end up with sine 60. So now, if cos 30 corresponds to sine 60, then I can substitute. So definitely, sine 2x plus 10 will be equals to sine 60. Now, for this statement to be true, then 2x plus 10 must be equal to 60. You don't need to cancel the sign. This is just like by reasoning. If this 2x plus 10 is nothing but 60, then this wouldn't have been true. So it has to be equal to 60. Then the goal is to solve for x. Then we have 2x to be equals to 60 minus 10, which will be 2x equals 50. And dividing through by 2, we end up having the value of x to be equals to 25. And that is the solution to this problem. So now, what if we want to use the other formula? Or for instance, you want to use the other formula, that of sine theta equals cos 90 minus theta. So now, I want to consider the sine of 2x plus 10. Sine 2x plus 10 will correspond to cos 90 minus in the bracket 2x plus 10. Hopefully you got that. Now, if we simplify that, we end up with cos 90 minus 2x minus 10, which will become cos 90 minus 10. That will result in 80 minus 2x. Now, we can actually substitute back. If sine 2x plus 10 is cos 80 minus 2x, then definitely cos 80 minus 2x must be equals to cos 30. Now, for these statements to be true, then the angles must be equal to themselves. So 80 minus 2x must be equals to 30. And the goal is to solve for x. What if I bring 2x to this side and take 30 to that side? Then we should end up with 80 minus x, or 80 minus 30 to be equals to 2x, and 50 equals 2x. Dividing 2 by 2 will result in x to be equals to 25. And we have our final answer. As you can see, we end up with the same thing. And that is how to deal with problems involving trigonometric ratio of complementary angles. Hopefully you found that helpful. Example 2. Consider cos 40 minus x to be equals to sine 70. What would be the value of x? So we know that sine 70 will be the same as cos 90 minus 70. and therefore that will result in cos 20. If that is the case, I can replace sine 70 with cos 20, and therefore I can have cos 40 minus x to be equals to cos 20. And for this to be true, 40 minus x must be equals to 20. Taking x to this side, bringing 20, then we have 40 minus 20 to be equals to x, and x results in 20. And this is our final answer. However, you can use the other way around to solve for the value of x. In the end, you would end up with 20. Example number 3. Cot 54 divided by tan 36. What would have been the answer? Well, we know that tan 36 is equals to cot 90 minus 36. And therefore, that will result in cot. I wrote cot, not cos, please. That will result in cot 90 minus 36. That will be 54. And finally, if I substitute cot 54 for tan 36, then I'll end up with cot 54. Oops. Cot 54 divided by cot 54, which will result in 1. You can always confirm your solutions with calculator if you have the privilege. And this is how to deal with problems involving trigonometric ratio of complementary angles. Hopefully you find this helpful. Thanks for watching. See you guys in the next video. If you have any question, feel free to drop it in the comment section below. This is your exercise. Let me know your solution in the comment section below. Bye for now.